So today we're talking about special right triangles. And when we use the word special, we're really referring to two types of triangles. The first one is an isosceles right triangle. That would be a triangle that has a right angle, so 90 degrees, and it has two sides that have the same length, isosceles right. The other type of special right triangle is a 30, 60, 90 degree triangle. It has one angle that measures 30 degrees, another that measures 60, and another that measures 90. So now let's look closer to figure out what's special about these types of triangles. So we'll start out by looking at our isosceles right triangle. It's also called a 45, 45, 90 triangle. And what we want to do here is just label this triangle. So I'm going to label this 45 degrees. And this 45 degrees, and this one's 90 degrees. Now, my 45 degree angles are going to be opposite of the legs, and those legs have the same length. In this case, we're going to use x for both of those legs. The 90 degree angle will be opposite of the hypotenuse. So we've done these. The last side, the hypotenuse, is going to be x times the square root of 2. So why is that? Why is that always going to be the leg length multiplied by the square root of 2? Well, you can use the Pythagorean theorem to find why. So if you have an isosceles right triangle and the legs have a side length of x, you could use the Pythagorean theorem to write that x squared plus x squared equals the hypotenuse squared. So then let's just see if we can solve for the hypotenuse. Well, I can add these two together. That gives me 2x squared equals the hypotenuse squared. My next step will be to take the square root of both sides. So now my hypotenuse is going to be equal to the square root of 2x squared. And I know the square root of x squared is just x. So x times the square root of 2. And look, that's exactly what we have for a hypotenuse here. So the ratios of the side lengths of an isosceles right triangle will always be x, x, x square root 2. The legs are going to be opposite of the 45 degree angles, and they'll have a measure of x. And then the hypotenuse will be opposite the 90 degree angle, and it will have a measure of x square root 2. So obviously, we don't just want to have a bunch of x's for our triangle. We want to look at actual side lengths. So here we have a triangle. It's an isosceles right triangle. This tells us that right there. And we have a side length, a leg length of 2 here. So if one leg is 2, what's the other leg? It's also 2 because this is isosceles. I labeled my angles there. It's not really necessary, but it can be helpful. And then I can see that my hypotenuse is going to be opposite of the side that's equal to x times the square root of 2. So in this case, x is equal to 2. That's the length of my legs. So what would x square root of 2 be? Well, I'm going to substitute 2 in place of x, and that gives me 2 square root 2. X is 2, x is 2, x square root 2 is 2 square root 2. So I was able to find the hypotenuse without doing the Pythagorean theorem or without doing any calculations. I just used my ratio. Let's look at another one. This one gives us the hypotenuse, but it doesn't give us the legs. This is an isosceles right triangle, so I'm just going to go ahead and label those angles right there. And I know my 90 degrees is opposite of my hypotenuse, and my hypotenuse is equal to x square root 2. So 1.3 equals x times square root 2. That's a one-step equation. To solve it for x, I just need to divide both sides by the square root of 2. So then my square root 2's cancel out over here, and I know that x is going to be equal to 1.3 divided by the square root of 2. Let's type that in our calculators. So my calculator told me that x is going to be equal to 92 hundredths, so I'm just going to write that in here. So I've labeled that for both of the legs of my triangle, and then let me write it in my table as well. And a simple way to check my work here would just be to use the Pythagorean theorem. Let's see if this works. Does a squared plus b squared equal c squared? Check it out in your calculator really quick. Yes, it does. So that suggests that we did this correctly. So now let's look at 30, 60, 90 triangles. So here I've got a 30, 60, 90 degree triangle. My 90 degree angle has this little box here. And once again, that's opposite of the hypotenuse. My 60 degree angle is a little bit bigger than my 30 degree angle. And I'm just going to use my table to fill in my side lengths. It tells me that x is opposite of my 30-degree angle, that x square root 3 is opposite of the 60-degree angle, and finally 2x is my hypotenuse. That's opposite the 90-degree angle. So why would this be the case? Why would I have these ratios? To understand the y of a 30, 60, 90 triangle, you have to first start with an equilateral triangle. Equilateral triangles are also equiangular, which means that each angle is 60 degrees. So what I'm going to do here is split this equilateral triangle into two equal halves by drawing a line from the vertex to the center of my base. And I'm just going to use x to represent this side length right here. Of course, if that side length is x, just that half of the triangle there, then all the way across must be 2x, right? And if the base of this triangle is 2x, then all of the sides are 2x. Okay, so now let's just talk about this part of the triangle that I have shaded in right here. It has a 60-degree angle in the bottom right-hand corner. I know that this would be 90 degrees, and then my top angle is going to be half of 60 because I am bisecting that top angle. Well, half of 60 is 30, so this one must be 30 degrees. So here I have a 30, 60, 90-degree triangle. Cool. My bottom leg here, my shorter leg, is x long, and my hypotenuse is 2x. Well, what about my longer leg? What would that be? We can use the Pythagorean Theorem to figure this out as well. My shorter leg measures x, and my hypotenuse measures 2x. And what I want to find is my longer leg. Okay, so let's substitute those values in there and figure this out. Let's see. I squared 2x to get 4x squared, and now I have x squared plus b squared equals 4x squared. Let me get my x's together by subtracting x squared from both sides, and that's going to give me b squared equals 3x squared. Cool, let's figure out what b is by taking the square root of both sides. So that's going to say that b is equal to the square root of 3x squared. And of course, the square root of x squared is just x. So b is going to equal x times the square root of 3. So this is why I have the ratio x square root 3, and 2x for my side lengths on a 30, 60, 90 triangle. So let's look at an example where we know one of the side lengths. In this one down here, we know that our hypotenuse measures 4. Remember, that's the side opposite of the 90-degree angle. I'll go ahead and label my other angles as well. I have my 60-degree angle up top, and my 30-degree angle is smaller down here on the bottom. So my side that's opposite my 90-degree angle is my hypotenuse, and I know that's equal to 2x. So here, once again, I have a little one-step equation. I know that 4 equals 2x. Let's divide both sides by 2, and that tells me that x is equal to 2. Well, I know that the side length that's opposite of the 30 is my x. So let me label that there. And my longer leg is going to be x square root 3. Now that I know what x is, I know that the side opposite the 30 must measure 2. And the side that's opposite the 60 must be 2 square root 3. There we go. So I know my side lengths. Let me write these in my table. I started by finding that 2x was equal to 4. That was given to me. Remember, that was on the diagram right there. That told me that x must be 2. Using that, I knew that this side was 2, and that the side opposite 60 was 2 square root 3. All I did was substitute 2 in place of x. How about one more? Once again, I want to start out by labeling my angles. So I have 90 degrees down here. That's usually the easiest one to find. I have 30 degrees, and I have 60 degrees. I know that the side that's opposite 90 is my hypotenuse, and that would be 2x. The side that's opposite the 30 is my shortest leg, and that's just x. The other one is my longer leg, and that would be x square root 3. In this case, the side length we know is the one that's x square root 3. Specifically, we know that x square root 3 is equal to 9 yards. So let's solve this one-step equation by dividing both sides by the square root of 3. So I know that x is going to equal 9 divided by the square root of 3. Let's type that in our calculator and see what it is. My calculator told me that x is going to be 5.2. So let me write 5.2 over here by x. Well, if 5.2 is x, what would 2x be? That would just be 2 times 5.2. So 2x is 2 times 5.2. That's going to be 10.4. So my hypotenuse here is 10.4. Let's write that in our table. So once again, we can use the Pythagorean theorem to check this. Let's try it out. Is 5.2 squared plus 9 squared equal to 10.4 squared? Try it out in your calculator. See if it's true. And yes, it is, which means that we did this one right also.